them in one class. It's funny. Testing a shadow-proof class. It worked fine. Okay. Does that kind of make sense? I'm not going to get very deep into the math that he did, because some of it requires math that's beyond most of us in here. But does the idea itself make sense? If you had a bunch of data really low, really high, the mean could come out to be in the middle with nothing around it. Of course it could. 1, 1, 1, 1, 1, 1, 1, 8 billion, 8 billion, 8 billion, 8 billion, 8 billion. The mean is in the middle, nothing's around it, right? For a little thing. Okay, maybe. The second thing he says is, if you take one more step out, not only must you collect some data points, in this case some people, but you have to collect at least 75% of the data. So within 2 standard deviations, there's at least 75% of the data. Now that is powerful. The first one is like, wow, how many points you think the Panthers were going to win before the Super Bowl happened, and even the commercials didn't save it. At least 0. Wow, way to go out on a limb there, right? So the first thing he says is kind of lame. The second thing, though, is amazing. If you think about it, no matter what data you come up with, I really want you guys, and some of you guys are like, playing with numbers, it sounds great. But no matter what set of data you ever came up with, or anybody in the universe ever came up with, if I calculate the mean and the standard deviation, and I go 2 steps up and down, I will catch at least 75%, no matter what the list of numbers look like. No matter what. And somehow this dude had enough time in his hands in Russia, I don't know, during the winter back then, it was like, you just stayed inside. Prayed the bears would just stay away. Right? Hibernate, bears, go on. And then, just to finish that, within 3 standard deviations, there's at least 89% of the data. 89% of the data. So very quickly, I'm not going to prove this, my God. Right? It took this guy a while to do it. I'm going to prove it to you. But why does this also make sense? What if I was God, or your favorite deity, whatever, and I reached down and I made these people younger and these people older? In an attempt, God says, Chevy, I just call him Chubby Dude. This is the Chebyshev's theorem. I call him Chubby Dude, poor guy. I don't know if he's chubby. Probably not. If I'm God, I say, okay, Chubby Dude, I don't want that 75%. I'm going to pull these apart now. I'm going to make these people older. These people younger. And some of them are not even born yet. Why does this still kind of hold? I said this earlier. If I move them apart, the standard deviation gets bigger. So it's like I can't escape. Does that make sense? I like it. So that's not a proof, but it explains a little bit of the reasoning why this kind of makes sense. You just can't escape. I don't care if you pull them apart. You can't. It's like these get bigger. Can't escape. I like it. And these are at least. It says at least. So what do we get? 56.3. Is that at least 0? Yes. That's not a proof either, but if I did within 2 steps, I'd have to get at least 75%. And for a small set of data, it's normally close to 100. Okay, maybe you guys are with me. So that's Chubby Dude's theorem, right? Chebyshev. Let's talk about empirical theorem, and then we'll take a step back and see what else I've missed here. So when you guys did the quiz, I think most of you should have gotten something that looked sort of like that. And some of you guys might not have. I didn't really check all of them, but they should have been something close, depending on how you picture classes. So I don't know if I've said this word yet, but that's roughly, I think I did. It looks like a bell curve. Looks like what is it officially called? Normal curve. I like it. I like it. More general class of it is Gaussian curves, but we'll just call it normal curve. Makes it make sense. So if I have a normal curve, what's automatically different? If I know that it's normally distributed, my stuff is normally distributed, which means what? It must look like a bell, so it's got to be highest where? In the middle. So there's no way in hell that first statement of Chebyshev's could be true about these specifically. It's still true because it's at least 0%, but we could be a lot more specific now because these have to have a certain shape. They have to be highest in the middle. So for normal distributions, we have what's called the empirical rule. It says within one standard deviation of the mean, there's exactly, well, this is still an approximation, but 68%. It's actually 68.26 or whatever. So we'll say it's 68%. So for example, let's finish this out. Within 2, there's exactly 95%. Within 3, there's exactly 99.7%. Oh, holy shit. So it's kind of neat. So very rough example for you guys. Let me give you something concrete to work with. The average height of men, U.S. men, let's say, because every country is a little different, right? The average height of U.S. men, the last time I looked, it was like 69 inches with a standard deviation of 2. Let's make it 2.5. I can't remember exactly what it is, but that'll make it easier to work with. Let's say that's true, right? I want to give you a real, concrete, practical application of this. So doing what we just did here, in the middle I would put my mean. Now, step up a couple and step down a couple standard. If I take one step up, where do I end up? One standard deviation up. 71.5, I like it. Take one more step up. 74, I like it. Take one step down.
66.5.
And another step down. So can we all agree right now, a really good way to identify these quickly is there, do you see what I mean if I call this 0 and I call this 1 and I call that -1? What are those? Be more specific. Those are blank blanks. Z-scores. That's 1 because it's one step up, and that's -1 because it's one step down. So this would be a z-score of 2, z-score -2. So now watch. Why do they make doors as tall as they do? Let me see if you guys are with me. What percentage of men? And I know that heights are normally distributed. In fact, that's sort of like why I explained it. Why is it called normal? Because normally most men will be around the average. And there'll be a few that are shorter and a few that are taller, right? Is everybody kind of with me? So that's sort of like where that name, if things happen normally, so you don't eat the wrong kind of food or whatever, and you just progress normally as you grow, you should follow this curve. You guys kind of with me? Okay, maybe sort of like where the name came from, not exactly, but I won't. I know it's normally distributed, so do I use chubby dude or empirical rule? Empirical rule. I know more specifically what's going on. So what percentage of men must be in there? Yeah, because I went 2 steps out. There must be 95% of all men are between those two heights. That, I really hope you understand. All I had to do was get a feel for this. I could do this with a sample of American men. Take like 800 American men, get their average, get the standard deviation, and then I have a really good approximation for where are 95% of the men. What are their heights between? Bam. And then I can design freaking doors correctly. If I had the door, let me see if you guys are with me. So is everybody with me so far? This is 95%. Why? Where'd that come from? Because I'm within 2 steps. Bam, bam. I know it's normal. I caught 95% of all men. U.S. men, sorry. So if I made my door 74 inches tall, what percent of men would have to duck to get through the door? If there's 95% in here, how much is out here? 5%. So how much is over there? So if I made my door 74 inches tall, 2.5% of all men would have to duck or hit their head. Right? You guys kind of with me? Does that make sense? Yes, sir.
How did you get 95% again? Oh, okay.
Since I went 2 steps out, so what percentage is in here? 68. So these numbers I want you to, I require you to memorize. Chubby dude, don't worry about too much. There's some homework problems involving, but this is the one I'm going to ask you questions on the test. You're not allowed to write those numbers down. You have to know those numbers. 3 numbers, right? Is everybody cool with that? Where that 2.5% came from? Some of you guys are like, that makes too much sense to be, that can't be right. Makes too much sense. So the door, I think a while back we measured the door. It actually came out to be 76 inches tall, I think. If it was this door, I can't remember what room I was in. And why does that make sense? Maybe 2.5 is a little too much for me to handle as far as handling complaints. So we made it a little bit taller, so a smaller percentage of men would have to duck. Does that kind of make sense? If we were all hobbits, we probably wouldn't have doors that big, right? We'd be, over here. Well, you're tall. Hobbit, you're 4 feet tall. Get over here. Okay, maybe. Poor hobbits, I'm sorry. If you're a hobbit, I apologize. Yes?
Is the 2.5% taken from the standard deviation, or is it just...
If there's 95% of all men in here, what percentage is not in there? So smaller or taller? What percentage is outside? 95% inside? What percentage out? 5%. So what percentage on that side? 2.5%. And it's because a normal curve is symmetric. Boogie. Because then I know I can cut things in half around the mean because it's symmetric. I like it. In general, I don't know. But if it's a normal curve, I know it's symmetric. How are we doing so far? Are we feeling all right? Okay. Let's see. Well, all right. There's nothing. So there are a few problems in the homework with Chebyshev and Empirical. I hope you realize they're going to have to tell you the mean. They're going to have to tell you the standard deviation, or give you a list and you put it into L1, you calculate it. And then you can put the mean in the middle and just start stepping up and down. You can answer all kinds of questions. What percentage of men are over 74 inches? 2.5%. Next, right? So if you just create this for yourself, those kind of questions are easy. Okay, I like it. Oh, let's see, what else was there? One more thing. Oh, I like it. Okay. Time we got. Oh, let me do this. Let me give you guys a problem to try. Given u equal 180. Derivation of 5. Normal curve. What do you got, Jeff? All right. So part A should be easy. Part B is a little more challenging. So everybody understand the question? It's exactly the same kind of question we asked here. While you guys are doing it, I'm going to pass out the practice test. Yeah. Oh, did I miss? Oh, there's one more coming? So we need one more. Oh, you got it? Okay, good. I can't count. Everybody got one? Good. Yeah. So this is what you can create for yourself to answer these questions, right? Start with the middle is 20. Step up and down, step up and down, step up and down. Now I can answer these questions. Between 5 and 35, that's directly from the empirical rule. Within 3 steps, there's what percentage of the data for a normal curve? 99.7. Sounds like that old soap commercial. 99 and 4,400% pure. Might be before you talk about it. 99.7%. That's between 5 and 35. And then, how about 5 and 10? Now we're getting there. Just in here, just that. Oh shit.
1.5%.
So how did you figure it out? Who's got a method they know worked? Yes, sir. You. Or either way.
If between steps or deviation 2 and 3, there's only 2.7%
But how do you know?
between the two, because there's 95% between 3 and 97.7 between 2.
All right. So you got there's 99.7 here, and then here
There's 95%.
there's 95.
So it's 2.7%.
Yeah, but where's that 2.7%?
It's on both sides. So
Good.
You divide by 2.
Beautiful. All right, that's one way to do it. That's just one way to do it. There's 99.7 this here, right? That's what we got in the first. There's 95 from here to here, right? So then what must there be from here and there? There must be, subtract these. It's how much is outside, isn't it? So if you subtract these, you get 2.7. If you cut it in half, you get this side only. What's up? 4.7. Oh, I keep saying 95. Yeah, okay. 4.7. Cut that in half. That's 2.35. Okay, that's better. So 2.35% there. I mean, and there's other ways to do it, right? You can do it based on half of it. Anybody know what percentage there must be from here to here? Well, that's half of what?
30.
Yes, 34, right? Half of 68. Because again, the middle is it's symmetric around the middle. You just cut things in half around the middle. You start to see how to play with those numbers a little bit. So that's not bad yet. When we start right now, we only know 1, 2, 3. That's all we know is empirical rule. We are eventually going to learn how to do 1.37 and know what percentage that is. But right now, we just know 1, 2, 3. So appreciate where you are right now. Right? All right, let me see. I think I caught up. That's all in section 2.7. I like it. Make sure I didn't miss anybody. No. All right, I like it. So, everybody got a practice test, right?
Yep.
So on Thursday, it's nothing but review for the test, because the test is happening when? A week from today. I like it. So on Thursday, we will do some more examples of standard deviation in the calculator. Right, so in case you need some more practice with that. Cool, because it's going to happen to you next Tuesday. All right, guys. Yeah. You can correct the quiz.
Oh, correct it and then bring it back?
Yeah.
Okay.
So you just correct what you got wrong, and if you do them all, you can get a certain number of points back. So if you got an 80 or above, you get 5 points back. If you do all the corrections, you get them all right. Below an 80, you get a point for every 4 you missed.
Okay.
So if you got a 60, you missed 40 divided by 10, you can get 10 points back.
Okay.
If you do all the corrections, get them all right.
Okay.
Yeah.
Yeah, that's cool.
Oh, okay.
I'll go see you on Thursday.
Sure.
Just want to let you know I got the
Oh, man. All right.
I'll try it again.
A little too much?
Yeah, just this and that.
Yeah. All right.
I ran out of time before I could turn the decimal into percentages.
You're fine. You can represent them as decimals, yeah.
I will not be here on Thursday because I'm going to a university interview. I don't know if
You shoot me an email, I can shoot you a copy of the answer.
Alright,
Yeah.
I'll do that.
Cool.
Alright, thank you.
Okay.
I turned my homework in, but I don't think there